Guys, what FabricPath is going to bring us is, well, actually, let's go back and do a little history. So FabricPath is based on Trill, or the transparent interconnect of a lot of links. And if you guys have never looked it up, Trill is actually, it's a fascinating technology. It's going to help us eliminate spanning tree from the data center. It's going to essentially allow us to route at layer 2 within the network, except now we're not going to be routing based on IP addresses or using MAC addresses. We're going to be routing using something called a switch ID. Okay. What's funny about it is Trill. One of the members of the board developing Trill is actually Radia Perlman. Does that name ring a bell? Does anyone remember her? What'd she help create? You're okay, Juan. Radia Perlman was also the inventor of spanning tree, right? I just think it's funny that she's on the board developing Trill to eliminate the protocol that she wrote for layer 2 loops. Okay. I find it funny anyway. Geek humor, I guess. But anyway, FabricPath is Cisco's implementation of Trill. Okay? Because Trill has not yet been fully ratified, I don't think. There was some reason Cisco did not actually implement Trill natively. They came up with FabricPath based on Trill. And it works great, guys. I've deployed FabricPath in quite a few different deployments now. Some really large FabricPath deployments. And it works really, really good inside a data center. Okay? It does, in fact, eliminate spanning tree within the data center. And it allows us to use equal cost multipathing between a source and destination. Okay? If we have, again, just like any routing protocol, if we have multiple paths from a source to a destination that are equal in cost, okay, it's going to allow us to take advantage of those multi-paths. Okay. Now, it also allows us to conserve CAN table space within our switches that run FabricPath. Okay. Right now, the switches that we're going to talk about in the context of the CCIE Data Center Lab that run FabricPath are specifically the Nexus 7K with the F-type card, okay, and the Nexus 55XX, okay, so 5548 or 5596 can run it. Specifically for us, we're going to be talking about the 5548, okay. Now, in the background, with all this FabricPath running, there's a protocol behind the scenes that's helping us out. That protocol is actually IS to IS. Okay, or intermediate system to intermediate system. IS to IS was chosen because it is not dependent on IP. Okay, IS to IS can actually auto-configure itself at layer 2, form adjacencies, build routing tables, all of that without any user intervention on our part. Okay, so what's going to happen is we're going to enable FabricPath. You guys are going to see how easy it is to actually implement FabricPath. And when we go in there and do it, IS to IS is going to do its magic in the background. It's going to form adjacencies, exchange switch IDs. Everything's going to be done for us. Okay? But with that, we're actually going to have some additional overhead, like when we add anything, right? We're adding a FabricPath header now onto our frames. Okay? So we're going to add a 16-byte MAC and MAC header to our existing Ethernet frame. Why is my pen not working? We're going to add a 16-byte MAC and MAC frame to our Ethernet header. Okay? There's some core components in here that I want you guys to understand. We're going to have what we call an outer destination address and an outer source address. These are going to be our switch IDs, guys. Each switch in the network is going to be assigned a switch ID. Okay? We're either going to statically assign that switch ID or we're going to let it dynamically assign through a process called DRAP, or Dynamic Resource Allocation Protocol. Now, when we dive this out and I start diagramming a network, you guys are going to see why we would want to always statically assign an address when we're running FabricPath. If we let DRAP dynamically assign it, our routing tables, troubleshooting, all that's not going to be as clear as it will be if we go in there and statically assign them. Again, you'll see this, but just imagine routing based on individual IP addresses, and you're letting DHCP dole those out. So when you look at a routing table and you're looking at a specific entry, you have really no idea where that IP address is because it's been dynamically assigned. It has no meaning to you. When we statically assign these switch IDs, they're going to have some meaning to you. You're going to know what switch 51 is, what 52, 71, 72, okay? because again, they'll have some meaning. You actually went in there as the administrator and assigned them, okay? Now we're also, the only other real part of this header I want you guys to worry about is called the F tag, or what we're gonna refer to as the forwarding tag, okay? The F tag is gonna help us identify what topology we're using. So if we're using, if it's a unicast flow, the F tag is going to identify the topology that we're using. Okay? If it is a multi-destination flow, or a multicast, broadcast, unknown unicast flow, it's going to identify the multi-destination tree that we're going to be using. So if it's, we'll say multi-destination, the F tag will equal our tree. Okay? And we're going to talk about these trees here in just a minute. Okay? But I want you guys to know that this F tag is significant within this header. We do need to know what these F tags correlate to, because it's going to give us a more deterministic way to troubleshoot certain flows of traffic. Okay? Especially if you're using Wireshark to capture packets, it's going to help us out. All right? We're also going to change the ether type, right? Because if we're not actually running native Ethernet, we're going to have an ether type. For 8903 or 0x8903 is actually the ether type for FabricPath. And we also are going to have some loop prevention with this, because again, we're bringing routing down to layer 2. Okay? We know inherently layer 2 can loop, and it can be catastrophic within our data center. So we need some basic loop prevention mechanisms. What we're going to see is these trees are going to provide us with one. Another one we brought in from the routing fields itself, right? We brought in the old TTL field, okay? Everyone knows what TTL is, right? Time to live. So if it starts bouncing, if a frame starts bouncing through our FabricPath topology, and for some reason, I don't know why, if it starts looping, we're going to decrement this TTL with every switch hop, okay? If it gets to 0, we're going to drop it. Again, basic loop prevention mechanism within the network. It was a good field to bring along, okay? Now, with all this said, we are running IS to IS, okay? We are running IS to IS to help us route these frames back and forth within our data center when we're using FabricPath. We're only going to be kind of, if you guys are familiar with IS to IS at all, we're going to be forming what we call L1 adjacencies, okay? We're not going to have any L2 adjacencies. Everything's going to be at L1, okay? And for the scope of this lab, I want you guys to know we're only going to be referencing what we call one topology, okay? That topology is 0, all right? So within the scope of this lab, there are more topology scope, but especially for you guys that have never dealt with FabricPath before, I don't want you guys to worry about those other topologies right now. We're going to concentrate on a single topology deployment, so for the sake of this conversation, we're always talking topology 0, all right? When we build topology 0, we're also going to know what these multi-destination trees are that I referenced a minute ago. Again, they are a basic loop prevention mechanism for us, okay? What they are going to do, it's going to look a little like spanning tree, guys. These multi-destination trees, we're going to route certain types of traffic, okay? For tree 1, we're going to see this is going to be our route for all broadcast, all multicast, or not all multicast, some multicast, and unknown unicast. Okay? Write that down. That's important. Tree 2 is going to be other multicast. Okay? And multicast will pick which tree it's going to flow on based on a specific algorithm that they're running in the background. Okay? So we have tree 1 and tree 2. We have to be cognizant of which tree is which. Okay? Now, when we form these trees, we're going to see that it's going to look just like spanning tree. We're going to form a shortest path tree to that multi-destination tree route, meaning each one of these trees, 1 and 2, is going to have essentially a route bridge. Okay, it's not actually called a route bridge, but that's what I'm going to convey it to you guys as. It is correlated as the route for that tree. So we're going to, in essence, going to end up with something that could look like this, could branch off, and we're going to form a multi-destination tree. Okay? Everything will be routed up to that tree, and it will guarantee that flows like broadcast traffic, multicast traffic, do not loop within our FabricPath domain. Okay? Now again, we're going to have one route for tree 1, and we're going to have another route for tree 2. Okay? So we'll end up with some trees that look about like this. These guys could even be connected. This could be a large network, right? He could be the tree for 1, he could be the tree for 2, and that's how they would flow, okay? Now, we're going to have to elect these tree members, okay? Whoever is the root of these trees has to be elected, okay? Now, by default, we're going to be talking about what kind of technology here, layer 2 or layer 3, do you guys think? Two? Okay, yeah, you guys are wrong. We're bringing routing concepts to layer 2, okay? So we're really going to consider this a FabricPath as a layer 3 type of technology because we are going to have routing tables, we are going to have adjacencies. So therefore, when we have this election, the priority values that we're referencing, higher is going to be better, okay? So by default, all of the priorities are going to be equal, okay? We're going to have prios, I believe, of 64, okay? And we can scale that anywhere from 0 to 255, okay? So 255 is the highest we can go. All things equal, we are going to base whoever is the root for tree 1 is going to be the switch with the highest system ID, okay? So again, we're leaving it up to fate, okay? Tree 2 would be the second highest system ID, all right? So when we go and we want to manually configure this, we want the highest priority to be on the switch that we want to be the root for tree 1. So whoever is the highest, whether that is our switch ID or our priority, is going to be the root for tree 1. Whoever is the second highest is going to be the root for tree 2. Okay, so again, what Jason does in these scenarios is when I pick a switch that I want to be the root for tree 1, I'm going to assign a priority of 255. Okay, when I go and want the tree or the root for tree 2, I'm going to assign a priority of 254. That way I know, hey, this guy is going to always be the root for tree 1. This guy is always going to be the root for tree 2. Okay? That's how I kind of jive with this. What you're going to see is tree 1 is elected first. When the topology has its initial election, they're going to elect the switch with the highest system ID or the highest priority as the root for tree 1. Then the election happens for tree 2, and tree 1, whoever became the root for tree 1, is actually going to broadcast the root for tree 2 out to the rest of the network. Okay? So that's kind of how the election goes for those trees. But I'm going to show you guys through some output because a lot of people get confused. There's a couple ways we can verify who is what tree's root, okay? And there's one command I've been seeing a lot of CCIE candidates use, and they're like, why is this guy the root for both trees? I can't figure it out. So I'm going to show you that command so you don't make that same mistake, okay? So this is, again, the basics for spanning tree, or for FabricPath, okay? We're going to start getting into the guts of it here in just a second. We're going to diagram it out. I'm going to show you the real benefits and how this CAM table realization, how we can actually reduce the size of these CAM tables through what we call Conversational MAC Learning, okay? So let's cruise over here to the next page. We're also, because we're routing, guys, we're also going to be using costs on our links. IS to IS, again, is a link state routing protocol, so it is going to use interface costs, okay, in accordance with what we call, in OSPF as well, a reference bandwidth. So the reference bandwidth for IS to IS in this deployment is 400 gigabits per second, okay? That is going to end up giving us a 10 gig link equals a cost of 40. Okay, if we bundle that into a port channel, it is now a cost of 20. All right, if we have 2 links. So 10 gig links will always equal 40. All right, we can manually tune that through the use of a FabricPath IS to IS metric command on a per interface basis. All right, now would I recommend doing this? No. Mainly because if we go into a deployment, most of our links are going to be of like types, okay? So we're going to be able to realize this equal cost multipathing. I will give you the one instance that I would change this, and that's if we use port channels between our FabricPath nodes, okay? Beyond that, I wouldn't change this unless you're specifically asked in the exam to do some kind of traffic steering, okay? Now, this is the biggie, guys. Conversational MAC learning. And I want to start diagramming this out so that you guys can see how this conversational MAC learning works. In essence, what we're doing with conversational MAC learning is saying, I will not learn a MAC address unless the destination MAC is already in my table. Okay? That is pretty much the gist of conversational MAC learning. Now, with a true FabricPath deployment, what Cisco classifies is we have two different node types, okay? So we're gonna have, I'm gonna draw some 7Ks up here. So we'll say 7K1, (7K2). I'll draw a 5K1. And 5K2, okay? What we're gonna do is dual home these guys. Okay, we'll also throw a link in between the 7Ks here. Give me half a second. Zoom this in for you guys. Okay, so what we want to do is define what these node types are, kind of in accordance with what Cisco would describe them as. So if we have a pure FabricPath switch, i.e. it's not running any classical Ethernet VLANs, this would typically be what they consider a spine switch or a FabricPath spine. Okay, and these ones down here that may have, you know, some servers hanging off of them or may have some links to some other networks or some other switches would be what we consider leaf nodes. Okay, so this would be our leaf. Again, because they're going to have some classical Ethernet hanging off of them. Now, when we build this network, guys, what you're going to see is that oftentimes these 7Ks are going to have what we call mixed chassis, in that they're going to have both M cards and F cards in the same VDC. Now, on a true spine FabricPath switch, we would not see any MAC address entries when we did a show MAC address table. Okay, we wouldn't see anything. That's because of conversational MAC learning. But because of this mixed chassis mode, if we have both M1 and F1 cards in the same VDC that we're running FabricPath, okay, it's going to learn MAC addresses. Okay, it's just one of the pitfalls. If we're running in this mixed chassis mode, even at a true spine layer, we will learn MACs with these card combinations. Now, if we had a true FabricPath VDC where we're only running this F1 module, okay, we would not see the MAC addresses in there, okay? I just want to throw that out there because I get a lot of questions from students saying, hey, I've got the 7K ripped up, it's a spine, I don't have any classical Ethernet hanging off of it, but I'm still learning MAC addresses. Isn't the point of this that I reduce my CAM table size through conversational MAC learning? I'm like, well, yeah, do you have an M module in there in the same VDC? And they're like, yeah. Well, because the M module is kind of, it's what we're going to be using for routing in that mixed chassis mode. Because of that, it's going to have to inherently learn those MAC addresses, okay? Now, when we go to deploy this, guys, we have to do a couple things. So before I get into the whole flow of conversational MAC learning, let's define what we need to do, okay? We need to first enable the feature. Okay, now on the 7K, we're going to need to install the feature set and then enable the feature set. Okay, so I'm just going to say in broad terms that we need to enable the feature. The second thing we need to do, and the very first thing I always do, is define my switch IDs. Okay, so I'm going to come through here, and maybe 7K1, I'm going to say he is 71. Okay, maybe 7K2 is going to be switch ID 72, 5K1 is going to be 51, and 5K2 is going to be 52. Okay, so I've defined my switch IDs. The next thing I'm going to do is define my route. Okay, so define my routes. Okay, so I'm going to come in here and I'm going to decide which switches do I want to be my FabricPath routes, or yeah, my FabricPath routes for both of my trees. Okay, so for both of my multi-destination trees, I want to pick this out. So I might come in here and say I want 7K1 to be my route for tree 1. So I'm going to go in here and I'm going to assign a priority of 255 to this guy. And I'm going to assign a priority of 254 for this guy because maybe I want him to be my root for tree 2. Okay? So that's the third thing I usually do. I go in there and I'm going to immediately define my switch IDs and my roots for my 2 multi-destination trees. So again, he is going to be the root for tree 1. He is going to be the root for tree 2. Him for tree 1 because he has the highest. Him for tree 2 because he has the second highest priority. Okay? The fourth thing I'm going to do is enable my VLANs. Okay? We need to pick which VLANs we are going to be running FabricPath on, guys. All right? Meaning we have to go in and do something special to those VLANs. We need to enable those VLANs for FabricPath so that they can actually apply conversational MAC learning rules. Okay? So this is going to entail just going into our VLAN, so like VLAN 10, and saying mode FabricPath. Okay? This is going to turn that into a FabricPath VLAN at this point. All right? So it's going to start doing conversational MAC learning within the FabricPath core. All right? That is the fourth thing we need to do. And again, a good rule of thumb is that if it flows in your data center, enable it as a FabricPath VLAN. Okay? It's still going to be able to egress out on a classical Ethernet link, as we're going to see. Okay? The fifth thing we're going to do is enable interfaces. Okay, so we're going to go in our interface now and we're going to say switch mode FabricPath. All right, so on our links we're going to see that we have this one, 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 this one as mode FabricPath. These 2 links to these servers would not be mode FabricPath, guys. Those are classical Ethernet ports. These servers do not understand FabricPath frames. Okay? So when we get this finished, when we have our VLANs defined, our interfaces are turned up for FabricPath, what's going to happen is IS to IS is going to auto-configure at layer 2, and it's going to start forming adjacencies, exchanging switch IDs, and creating routing tables based on those switch IDs. Okay? So just for an example, from 5K1's perspective here, he is going to see 2 equal cost paths to switch 52. Okay? His routing table, when we say show FabricPath route for switch ID 52, we're going to see an egress through this interface or this interface. Okay? Why? Because by default, all of these links are going to be 10 gigs, so they're all going to have a cost of 40. So he can use either path, and he's going to have a cost of 80 to reach 52. Okay? So this is us building our FabricPath out. All right? So this is really, guys, you're going to be amazed at how simple it is to actually go in and configure FabricPath. It is truly simple. The big downfall to FabricPath is the enormous and almost egregious costs of the licensing. Okay? The enhanced layer 2 licensing is really expensive, all right? And I have no idea why. If with a technology that I think is this phenomenal, they should create it on the cheap and really market it, okay? Because it works great, all right? So when we go in, we're going to configure this, we're going to get it all working. Now, how does the traffic flow? Okay, what is this conversational MAC learning all about? So let's kind of roll with it. Let's imagine that server here, server A, wants to get to server B. And I'm going to use this as their MAC address as well. So this guy's going to be A, and this guy's going to be B. Both of these, I'm just going to say for simplicity's sake, are off port 1.1 on both of these switches. Okay, so again, let me zoom in a little here. So what's going to happen? What happens? What type of frame is sent out? If these guys are on the same IP subnet, and server A needs to figure out what server B's MAC address is, what does he do to initiate that communications, guys? Any idea? Very good, Tim. He's going to send an ARP out, right? And an ARP is a broadcast frame. So according to our multi-destination trees, he's going to use which tree for his ARP? Okay, it's a broadcast, so he's going to use tree 1, right? So what we're going to get is that when we come over here, server A is going to send his frame in to 51. 51 because this is a classical Ethernet port, has to abide by the classical Ethernet rules off that port. So he is going to learn MAC A off of port 11, okay? Because that's classical Ethernet 101, right? So he's going to send that. He's going to say, okay, this is a broadcast frame. I need to send that up multi-destination tree 1, okay? So he's going to send that out this link, all right? He is the root of tree 1, so what he's going to do is send it out every link except the one it was received on. So he's going to send it out here, okay? And he's going to send it out here. Now switch 72 is not going to send it out because he received that frame from tree 1's root, okay? So he doesn't have anything else right now, so he's just going to drop it, okay? Now switch 52 here is going to receive that broadcast, and he is going to send it out to server B, all right? Server B is going to say, all right, man, yeah, that was me. So what I want to do is respond to this ARP request. So I'm going to send the reply back to 52, all right? 52 likewise is going to send that back out the same multi-destination tree that it learned the original frame from, okay? So he also has a classical Ethernet port here, so he needs to learn MAC B off of port 11, okay? And he is going to send that back out, all right? Tree 1, likewise, doesn't know where it's destined to, so he's going to broadcast that back out, tree 1. Okay? So when it gets back, when this frame gets back to switch 51, okay, what's going to happen is he is going to record that frame's MAC address. Okay? So he's going to say, I learned switch B, or sorry, MAC B, but instead of going to a physical port, I learned it from a switch ID. Okay, so I learned that MAC B is from switch ID 52. All right, and he's going to go ahead and forward that reply back on. Okay, and now that server A has the appropriate ARP information for server B, he's going to initiate the communications he was originally intending on starting. Okay, so this time, when he sends it, it is destined for MAC B, okay? So what happens is, this guy is going to say, okay, this is a unicast packet, okay? So I'm going to look up this MAC address, all right? He looks up and sees that MAC B is tied to switch ID 52, all right? So he's like, okay, now I need to do a route lookup to see where or how I can reach switch ID 52. So he looks in his FabricPath routing table and he sees that he has two equal cost paths, one up to this 7K, one up to this 7K, to reach switch 52. Okay? So he is going to hash and pick one of those links, okay, because any given flow, just like a port channel, is just going to take one link. He's going to hash it up one of those links. So just because it's clear, let's go up this side. So he's going to send it up, hash it up this link. 7K2 is going to get that frame, okay? Now, rather than looking all the way down at the MAC or beyond, right, he is just going to take a look at that FabricPath header. He's going to say, okay, this is destined to switch ID 52. Based on my routing table, my FabricPath routing table, the shortest cost path to switch ID 52 is down through here. So he's going to send that on to switch 52. Now when switch 52 gets this, because he now has a destination IP address in his table, he is going to learn the source A from switch 51. And he is going to send that on to B. Okay? Notice these switches up here did not learn any MAC addresses, guys. They didn't learn any MAC addresses. They don't even care about the MAC addresses. They looked at that FabricPath switch ID in the header and determined where they were going to forward that frame onto by looking at their FabricPath routing tables. Again, MAC address scalability here. We're going to save CAN table space by learning MAC addresses on a conversational basis. Again, we're not going to learn it if we don't have the destination already in our MAC table, and it's got to have bidirectional communications. okay? Meaning we're not going to learn the source MAC on a broadcast packet, okay? That wouldn't be conserving MAC space, right? If we learned every source MAC from a broadcast, just wouldn't make sense. So we're only going to learn it for these bidirectional communications and if we have the MAC already in our table, okay? The destination MAC. So this is conversational MAC learning. This is why at this spine layer, we can really start to conserve MAC address table space by just not learning any MAC addresses, okay? I will put this caveat in here though. I've deployed this several times. I have never had a deployment where I had a true spine layer, okay? It was always the case with the spine layer that I had some kind of Ethernet segment hanging off the back end, okay? And we maybe had, some kind of router up here that we were using to pass on our data center subnets through, okay? That was maybe going to our campus LAN, all right? So, again, I have never had a true spine layer, all right? Now, this, guys, is really the joys of FabricPath, all right? This conversational MAC learning along with the equal cost multipathing, along with the fact that there is no spanning tree running in this FabricPath core. It is a clean core, loop-free at layer 2 because we've introduced routing techniques down into that FabricPath core, okay? Now, with this, when we have this classical Ethernet segment hanging off here, guys, we have to be cognizant of a classic FabricPath screw-up, okay? When we have a FabricPath domain, we have to represent that FabricPath core as one big switch, okay? So we can draw, this is a fairly small deployment, right? We can draw a big box around here. To the rest of this network, we are going to appear as one switch, okay? That makes sense? When we look back, I've got a little tidbit here. We represent ourselves as this MAC address, okay? I don't even claim to remember this, but we have to remember that we are representing every FabricPath switch that has a classical Ethernet segment hanging off of it is going to use this as his representation to the classical Ethernet domain, okay? So I'm just gonna say .6000 for this case. Each one of these is going to broadcast BPDUs out with that .6000 MAC address. Okay? We cannot change this behavior. This implies that we have to be seen as the same switch to the rest of the network. Also, for every FabricPath VLAN that we have, guys, every FabricPath VLAN, we have to be the root bridge. Okay? We have to be the root bridge. We are and will shut down this port facing the classical Ethernet domain if we receive a superior BPDU inbound, okay? Meaning, we are running root guard, all right? These ports facing this classical Ethernet domain are running root guard. So when we actually bring that segment onto these FabricPath switches, we need to come in and adjust our spanning tree priority on both down to the same value to a point at which we will be the root bridge, okay? So we could come in and we could say, spanning tree, VLAN, 1 through 4094, priority, 4092, okay? Or 4096, sorry. We'd have to do this on both switches, all right? Both of them in this specific instance would be running root guard. If they saw the other switch send in a superior BPDU, it would fail, okay? What you're gonna get is that you'll get a layer 2 inconsistency on that VLAN. So essentially, if you have a specific VLAN out here, maybe this switch sends in a BPDU for VLAN 10 that has a spanning tree priority of 0, which is better than our 4096. We're going to get a layer 2 gateway inconsistency for VLAN 10 on those ports, okay? So we still will pass traffic, but VLAN 10 will no longer transit into our FabricPath core from that classical Ethernet segment. okay? It's bad juju. I was doing a migration once, and it actually happened where some switch sent in a superior BPD. We already had half our servers on the FabricPath core. We had another half on the Nortel side. And what happened is we got a superior BPDU sent in for a specific VLAN, and all of a sudden the servers that we had migrated and the servers that were still over in production were then cut off. All right, so it will happen. It can hinder you. So you need to be cognizant of it. We need to make sure that we adjust that priority down to where we are represented as the root bridge for that classical Ethernet domain. Okay. Now, I mentioned pseudo information earlier, so I have to mention it again here, because where we ran this command, okay, it affected every single VLAN, okay, whether that's classical Ethernet or FabricPath. When I ran this spanning tree VLAN 1 through 4094 priority command, it's always classical Ethernet VLAN or FabricPath VLAN. It's going to send out that priority value. What we can do here, imagine that within this FabricPath domain, we only had VLANs 10 through 20 running in FabricPath, okay? But we needed to make sure that in the future, we're kind of covering our own rears, right? So in the future, we knew we were going to be adding more, and maybe we didn't want an admin to come in and make the mistake of, configuring the new FabricPath VLAN. So maybe he came in later and configured 21, but he forgot to adjust the spanning tree priority, okay? So we have a way we can kind of cover our butts here. What we can do is come in and use that spanning tree pseudo information command again. Okay, we can say VLAN 1 through 4094 priority 4096. When we do this in correlation with FabricPath, we can run this command, but the only time it's going to apply this priority is if it's actually a FabricPath VLAN. Okay, so that's beautiful, right? We can cover the whole range of applicable VLANs, but it's only going to apply this priority to the VLANs that we have enabled for FabricPath. Okay, so whether we're sending that out on the classical Ethernet segment, whether it's down facing the server, we're only going to apply it on those VLANs that are enabled for FabricPath. Okay, so that's a beautiful solution to kind of cover your butt. Because rather than putting this in and automatically affecting, every single VLAN, whether it's classical Ethernet or FabricPath, because maybe you still had some switches out there, right? Maybe you still had some other switches on some other data center segments that you wanted to be root bridge for some of the classical Ethernet VLANs. But you knew that you had to make sure you were the root for the FabricPath VLANs, okay? You can run this command and basically just CYA, okay? So that's a nice little command to kind of save your butt, right? We used to have that problem when we'd have HSRP and you had to make sure that the HSRP active router for a specific VLAN was also the spanning tree root. And then, you get Joe admin come in and he configures a new VLAN, a new HSRP setup, but he doesn't do the spanning tree section. That's the same kind of thing we could run into here, all right? Someone could come in, configure a new FabricPath VLAN, but forget to go in and make it the root bridge. If you use pseudo information and run this VLAN priority command under there, you're going to affect only the FabricPath VLANs, but you can kind of encompass everything so that as they come in and add VLAN 21, it'll be automatically covered by that statement, okay? So this is really the gist, guys, of FabricPath. We can also layer some authentication in here. So we can authenticate both our neighbors. All right, and we're going to do this on a link by link basis. Okay, and we can also authenticate our LSAs. Or link state packets, sorry, I should say LSPs, our link state packets. So within our FabricPath domain itself, we can actually authenticate the IS to IS link state packets. So one, guys, if we actually erase that ugly P I just drew, okay, one is going to be more of a global, I kind of correlate it to, if we do the link state authentication, it's more like doing area-based authentication with OSPF. And if we do a link-by-link based authentication, so if we authenticate on the actual FabricPath link and we authenticate a specific neighbor, that's more like interface-based authentication with OSPF. But we can do either. I'm going to show you guys how to do that. It's 3 simple commands with the addition of a keychain. What you're going to see is the same 3 commands we use, which is authentication key, authentication check, and authentication type, are the same 3 commands we're going to use when we talk about overlay transport virtualization authentication later. Okay, so get used to the commands. Will kind of flow off your tongue after that, but I will show you how to do the authentication in my demo. Okay, we're also going to talk about VPC Plus, that other flavor of VPC I alluded to earlier. VPC Plus brings us the added benefit where we could have, a third server. Okay, so maybe we have server C. Instead of these two being separate 5Ks, they're going to form a VPC domain. Okay, we're going to connect C to both and run a VPC down to him. All right, so what's the benefit? How is this VPC Plus? Okay, what we're going to do, guys, is the first thing we have to do when we have this type of deployment is this is now a FabricPath link. Okay, it's still the VPC peer link, but instead of being switch mode trunk, we're now switch mode FabricPath. Okay, so these guys are actually going to be FabricPath neighbors. All right. Now, second, we have to come in and assign a FabricPath switch ID to the VPC domain. Okay, meaning we're going to go into VPC domain 11, and we're going to say FabricPath switch ID, and give it a number. So in this case, I like to combine. So he's 5.2, he's 5.1, or sorry, he's 5.1, he's 5.2, so we'll do like 5.1.2. We're actually assigning a FabricPath switch ID to the VPC domain. Okay, what we're going to see is that when he comes in off of a VPC member port now, okay, whether he comes in this side or this side, what's going to happen is his frame is going to be assigned 5.1.2. Okay, so we're now going to have what we call an emulated switch ID within FabricPath, meaning we have VPC Plus set up, and rather than like this guy, when he comes in, he gets tagged with 51, this guy comes in, he gets tagged with 52, he's going to get the benefit of being tagged by a switch ID that is shared between these two nodes. Okay, so when this comes in, imagine we're looking at one of these 7K routing tables now. If they're looking to get to 51, he's got this link to get to it, and this guy has this link to get to 51. Likewise, 52, they each have their individual links. But what if they're trying to get to 5.1.2? Since both of these 5K nodes share 5.1.2, he can actually go down this link or this link to get to 5.1.2. Okay, do you guys see the benefits of it? That's where VPC Plus really benefits. We get more redundant paths to these destinations. Okay, likewise, when we have 5.1.2 at this guy, he's going to have this link he can go down or this link he can go down. Okay, so we get more paths, we get redundancy for those guys, both through the VPC functionality that's extended down to them, but also within the FabricPath domain, in that we have more paths that are applicable to them as a destination. Okay, that is VPC Plus, guys. Again, it's not hard to configure. We're really just going to convert the peer link over to FabricPath, and we're going to set up the VPC Plus FabricPath switch ID under the VPC domain. Okay, what I want to do, okay, we've talked about a lot of FabricPath. I want to talk about, I've already kind of alluded to my steps, but I want to do a demo. So I want to this is my steps to FabricPath jazziness, as I say. I'm going to turn on the feature set. We're going to, like I mentioned earlier, just going to repeat so that you guys get the process down. We're going to do the switch IDs. We're going to assign the tree roots. Okay, we're going to do the VLANs, and we're going to do the interfaces. Then and only then, after we've verified that traffic's flowing, that adjacencies are up, will we actually do anything like authentication. Okay, never ever ever do authentication before you even verify that the topology is up in general. Okay, get it up again at the most basic level, and then layer that extra stuff on as you go. Okay, so again, I'm a big advocate of getting in there, doing the base config, the minimum configuration necessary, do your verification, and then start layering stuff on top of that. Okay, so hopefully you guys can see that I'm real process oriented. I take all of these technologies and I try to develop little workflows around them. I found that it helped me as a candidate and it helps me as an engineer. Okay, so let's go in and take a look at the topology we're going to use. Remember earlier we configured this as our VPC domain. So we had VPC domain 11 here. Okay, this was actually a VPC down to this FEX. What we're going to do is enable all of these links in FabricPath mode. Okay, so everything between the 5Ks and the 7Ks on the F modules we're going to enable as FabricPath. So I'm going to go through my process and show you how we build this out, and then I'll show you how to convert this to a peer link and configure a VPC Plus switch ID for this node, okay? Sure, yeah, take a 5-minute break and then I'll do the demo, guys. So we'll meet back here 55 after. That's fine. I'll just hang out here. Oh, my boring you, Stanley? Have you guys ever used a program called Synergy for extending your keyboard and mouse over a network? No? There's a couple good books out there. The number one book I always recommend to students is actually called Data Center Virtualization. Okay, I just typed it in the chat window there. It's written by a guy named Gustavo. Just a phenomenal book. It's almost end-to-end with the CCIE Data Center blueprint. Really, really good read. Of course, there's a bunch of others like NXOS version 2, which is a book written by Ron Fuller, which is really good. There's a bunch of UCS books out there, but a lot of them are out of date. I also liked a book called I/O Consolidation in the Data Center. Okay. Routing and multicasting knowledge, you're really going to benefit if you go through that NXOS book. NXOS Fundamentals by Ron Fuller and the Data Center Virtualization. They go through all the different routing that's within NXOS itself. So they're going to cover RIP, they're going to cover BGP, all kind of everything that NXOS does, even if it's not on the blueprint. So that'd be a good book for you to read. But beyond that, man, really you can't go wrong with going out there and looking at Cisco Live presentations. So anything from Cisco Live, like routing with NXOS, FabricPath, OTV, Just phenomenal resources out there, man, that are at your disposal. Do you have a Cisco Live 365 account? Yeah, they're phenomenal resources. Let me here's that book by Gustavo. I actually had a guy from Cisco in my last live class who works with Gustavo. So it is a phenomenal resource. Here's that other book I was telling you about, these NXOS and Nexus switching. Both are really good, man. Both are really good. This Data Center Virtualization is the first book I read in many, many years that I actually read end to end. Yep. Yep, definitely go through them. Definitely go through them. Okay, is Stan back yet? Let me set this guy up. Okay. Good deal. Yeah, for you guys who just got back, he was, yeah, and FabricPath, though it's really easy to configure, it does got a lot of stuff going on behind the scenes. So, yeah, you're going to lab it, though, and really you're going to find that the configuration of it's not that huge, okay? But you do need, as an expert, need to know what's going on kind of behind the curtains, if you will. Yeah, that Gustavo book's awesome. He's got a good sense of humor. Just a fun guy. He puts his personality kind of into his writing, and I personally love that, especially in a dry technology book, right? Okay, so let's go through this. The first thing I want to do on these 5Ks is I want to go into configuration mode and make sure that I install my feature set for FabricPath. Okay, so it tells me it's already installed. So I just want to enable it. So I'll say feature set FabricPath. Okay. If we do show feature set, I can see that FabricPath is enabled. So I want to say FabricPath Switch ID, and this is my 7K1. So I said I'm going to name that 71. So I'm going to say FabricPath Switch ID 71. Okay. The next thing I'm going to do is I'm going to make him the multi-destination root for tree 1. So I want to go into what we call FabricPath domain default. Okay. When we go into domain default, we're going to say role. Actually, let's go back and take a look at what we have available. We have some authentication. This is going to be our LSP-based authentication. But when we come down here, what we want to do is modify our root priority. Okay. So I'm going to say root priority, and then you see we have 1 through 255 with a default of 64. So I want to change that. I need to make him the highest on the network so that he will get the root privilege for tree 1. Okay, so I'm going to say root priority 255. All right. The next thing I'm going to do is define my VLANs. And since we said 10 through 20 earlier, I might as well just use 10 through 20 now. So I'm going to say VLAN 10 through 20, and I'm just going to say mode FabricPath. Okay, so we're just going to enable FabricPath or Conversational MAC Learning for those VLANs. So I'll hit enter. Now when we want to verify that, I'm just going to say show VLAN ID and just pick one out. When we say 15, I just chose one in the middle there. We can see the VLAN mode is FabricPath. Okay, if we look at like VLAN 1, what we're going to see is he is CE or Classical Ethernet. All right, so there's the difference. FabricPath, Classical Ethernet. All right, and actually if we go into any specific VLAN and we say mode question mark, we see those are only viable options. Okay, so now I've configured my switch ID, I've configured my tree priority, I've also configured my VLANs. So the last thing I need to do is configure my interfaces. So I want to click up here, and I have 4.1, 4.2, and 4.9 to configure. Okay? So I'm going to say interface Ethernet 4.1 through 2 and Ethernet 4.9. All I'm going to say, guys, again, is switch mode FabricPath and hit enter. Okay? Now, if we look, show module, I had to do that. The only module that understands, again, guys, I want to reiterate how important it is to know where your modules are in the system. The only module I have that will support FabricPath, that's able to actually decapsulate that FabricPath frame, is the F1 card, okay, which is on module 4. Had I tried module 3, we would have no success, okay? So I had to put that on module 4. Now, I've got my interfaces configured, my VLANs, my switch IDs, my routes, so I'm good to go. We can go configure the other switch. So I want to switch to N7K2. Okay? We're going to do the same thing. I'm going to say conf t, feature set, FabricPath. Okay? We're going to turn it on. I'm going to say FabricPath switch ID, he's going to be 72. Okay? Again, I'm manually assigning those. These are going to have more meaning to me when I look at the routing tables or later. Okay? The next thing I want to do, I just want to, let's see, 254. So I'm going to say FabricPath domain default. Now I want him to be the multi-destination route for tree 2. Okay? So I need to make him lower but still higher than 64. So I want to say root priority, and we'll just do 254. It's one lower than 255, but really a lot higher than 64, so that seems like a safe bet. So we'll say 254. Okay? The next thing I want to do is my VLANs. So I'm going to say VLANs 10 through 20. We'll say mode FabricPath. We'll exit out. We'll just verify. Show VLAN ID 15. Okay, mode FabricPath. And I need to do my interfaces. So we'll do 4.3, 4.4, and 4.13. Okay. So I'll say int e 4.3 through 4. Whoops. And e 4.13. That was 13, right? I always screw this one up, so I need to make sure. Yep, 13. Whoops. And we'll hit enter. So the next thing I'm going to do is say switch mode FabricPath. We'll no shut those guys. And we should be good from the 7K's perspective now. Oh. Sorry guys, hold on one second. Lost you. Okay. So the next thing I need to do is I need to go in and make sure, goodness gracious, I need to go in and make sure that my 5Ks are ready. So I want to go into this guy and I want to do the same thing. I'm going to install the feature set FabricPath. Okay, again, we need enhanced layer 2 licensing to do this. And I'm going to say feature set FabricPath. We'll do the same on switch 3. Okay. Now, I want to do my switch IDs first, so I'll say FabricPath switch ID. This one's going to be 51. Since I've already got my trees configured, I don't need to worry about that on the 5Ks. So I'm going to say VLANs 10 through 20. We'll say mode FabricPath. We'll verify. So I've got that in FabricPath. So the next thing I want to do, gosh, I don't know why that keeps pulling up. The next thing I want to do is configure my interfaces. So I've got 16 and 18 on this guy. So I'll say int e 116, e 118. and I'll say switch mode FabricPath. We'll no shut those guys as well. And we'll move over to switch 3. We'll do the same thing. We'll say FabricPath switch ID 52. We need to do our VLAN, so we'll say VLAN 10 through 20 mode FabricPath. Again, we'll exit out and we'll verify. We'll say show VLAN ID 15. Okay, so I know they're in FabricPath mode, or at least that one is, right? And then I'm going to go in and do my interfaces. So on this guy, the interfaces were a little different. So they were 16 and 17. So I'm going to say int E1 16 through 17. We'll say switch mode FabricPath. We'll no shut them. No shut. And we should, if we did everything correctly, have a converged topology. So how would we go about verifying that? If we look back at our diagram, the only things that are connected via FabricPath are from the 7K to the 5Ks. Okay, we have no links between the 5Ks. We kind of push everything down through our 7Ks. So I want to go to a 5K and just verify that I can see all of the different switch IDs within the fabric. Okay, so let's hop back to our 5Ks. I'll just use 5K2. I'm going to say show FabricPath switch ID. Okay. Now, if I can see all of the switch IDs from this topology, I know I'm right. I can see 51, 52, and 72. I can't see 71, so something is wrong on one of my links. So we need to, actually I bet I didn't no shut the interfaces over here because I can't see them anywhere. Notice when I'm looking at this, I don't see 71 anywhere, which means he's not, if he was even connected to 51 or 52, I'd be able to see the switch ID. The fact that I can't see 71 switch ID at all means that he's not connected to the fabric at all. So it probably means all his interfaces are shut down. So we'll go back over, we'll switch back, say show int status. Yep, they're all down. So we'll say conf t int e /1 through 2, e /9, no shut. Okay. Now, again, if everything worked, I should be able to say show FabricPath switch ID. And now I can see all the switch IDs. A little asterisk indicates that this is this system. Okay, so I'm seeing all of my switch IDs that I have in the fabric. So I know that I've converged at least from an IS to IS perspective. I also see that all of my switch IDs are static entries. Okay, like I said, when we do VPC Plus, we're going to see them start showing up as emulated entries, meaning they're shared between specific switches. So right now I can see all the switch IDs. I've actually built a routing table and adjacencies. So we can go in here and we can say show FabricPath IS to IS adjacency. And we can see that we have adjacencies with 7K2 and 7K1. We can even see what interfaces they're out of. Very cool, right? So as I mentioned before, it did all this automatically. We don't have to have any intimate knowledge of IS to IS to build this topology. Okay, it auto-configured everything for us. As we could see, it formed L1 adjacencies. Okay, they're all up right now. And if I say show FabricPath route, look at this. Now I see that I have a route to switch ID 51. Okay, switch ID 51, I can get through either 7K. Okay, so I can go up to 7K1 or 7K2. 7K1 I can get to through 117. 7K2 I can get through to 116. Very cool, right? That's our routing table for our FabricPath domain. That's why I'm saying it's important that we static these switch IDs. They need to have some meaning to you, okay? It's very important. Now, we've got this all up and running. I'd like to go in and show you guys how I can convert these 5Ks over to FabricPath mode, okay? I want to show you that when we come in and we want to turn them into where maybe these FEXs are represented as a VPC Plus switch ID, okay? It's a very easy conversion process, but we do need to do some troubleshooting along the way, okay? So the first thing I want to do is go back into our peer link, okay? So int port channel 1 in this case. And if we look at it, right now it's switch mode trunk. All I want to do is say switch mode FabricPath. Okay, just utterly tick off the peer link. Okay, so let's go in here now. convert this side, we'll say switch mode FabricPath. All right. We lost all of our fexes in this process, but what we can see here is a nice little message. Failed to bring up VPC Plus, PeerLink, port channel 1, and FabricPath port mode, but the VPC Plus FabricPath switch ID is not configured. It's telling us, okay, when NXOS tells you guys something, do yourselves a favor. Go in there and just do it right away so you don't forget it. So we want to go now into our VPC domain. So we're going to say VPC domain 11. All I'm going to say here is FabricPath switch ID, and we're just going to call it the FabricPath Plus switch ID is going to be 512. We're going to take just a merge of 51 and 52 and just create 512. And we'll hit enter. We'll type yes. We'll go to the other side and do the same thing. We'll say VPC domain 11, FabricPath switch ID 512. Yes. Okay. So what we're going to see now is that VPC is going to come back up. So we're going to see it's in FabricPath mode. What we want to see is that everything comes back up, including the PeerLink. All right. So it's thinking now. That's good that it's going through these steps. This means the election's happening. So we should be seeing it now. Okay. So now I can see that my VPC Plus switch ID is now 512. My PeerLink is okay. My peer keep alive is okay. I can reach my peer, okay, so I can reach my VPC peer through a FabricPath VLAN, all right? So now if we look at our VPC or our FabricPath table, if I say show FabricPath IS to IS adjacencies, now check this out. Now I have adjacencies between the 5Ks themselves, okay, over that peer link, right? I now have an adjacency with my other peer switch. All right, but VPC Plus is done. That's cool. So if we look now at our show FabricPath switch ID, check this out. Now, not only do I have my static switch IDs, right, I now have an emulated switch ID in the form of my VPC Plus switch ID. Okay, so now we see 512. It is an emulated ID. Okay, we can see yes. What's also cool is that 7F01 and 7D01 are the switches that make up that ID. So you can even backtrack. I can say 7D01, that is switch 51, and switch 7F01 is 52. So I know these two switches form that VPC Plus switch ID. Okay? You guys got that? So from a 7K's perspective now, if I say show FabricPath route, look at this. He's got one path to 51, one path to 52, but two different paths to 512. All right? Equal cost multipathing, baby. All right, you guys got that? That's the benefit of VPC Plus here. Now we've got redundant paths to redundant switches for redundant VPC down to a host or a switch or whatever's VPC connected to those to that VPC domain. Okay, so that, guys, is VPC Plus, an emulated switch ID. All right. The last thing I really want to show you, actually, there's two more things. I want to show you how we verify our multi-destination trees real quick. My command for that is show. Actually, let's do it from a 5K. Okay, clear off this junk. We'll say show FabricPath IS to IS topology summary. Okay, that is the command to verify our multi-destination trees. Okay, why did I have to do that? Okay, come on, Fexes.
Hello?
Okay, so now we see that we have two different trees. We have tree 1 and tree 2. I don't know why my phone just answered itself. But tree 1, okay, the tree ID 1, ftag 1, root system is tree 71. Okay, tree 2, ftag 2, root system is 72. There must be some kind of convergence going on right now in the... Sorry about that, I don't know what's going on. There's some kind of convergence going on. Okay, tree 2 is routed to tree 72. Okay, so we have verified, we need to do this from every switch in the topology though. So we say show FabricPath IS to IS topology summary. Okay, we can see that tree 71 and F tag tree 72. So we're good to go in terms of our trees elected properly. What I've seen that a lot of my students are doing is that they're trying to go in and verify. If they say show FabricPath IS to IS F tag, and they hit enter. Actually, no, it's show FabricPath IS to IS trees, maybe. No. Let me figure out the command because they're all using it. And maybe just F tag here. Yeah, this is the one they're using. So just show FabricPath F tag. So you're seeing the tree IDs here, but notice what we've got the same MAC address. Okay, so the same system ID. Notice what it says up here though. This is the allocating system ID. All right. So if we look back up and just say show FabricPath IS to IS topology summary again. If we look, the allocating system ID is actually tree 1 or 71. Okay, it is the allocating system ID because, like I mentioned when I talked about the election, he's going to get elected based on his highest priority, right? He's going to be elected for tree 1. The second election is going to take place, and he's going to broadcast that out. Whoever is the root for tree 2, he's going to say, "Hey, switch ID 72 is the root for tree 2." Okay, he's going to broadcast that out to the FabricPath domain. So he is the allocating system ID. So a lot of times, a lot of people are looking at this and they're saying, "Well, that's not right. That's the same switch as the root for both trees." That's not the case. Use this show FabricPath IS to IS topology summary and look at the tree ID and the correlating switch ID, which is shown at the end here. Okay. Now the last thing I'll show you before I'll turn you into labs is I want to show you a quick just interface-based authentication. So if we just look between, we'll just do between switch 1.1 and 2.1. Okay. So off 4.9, when we do authentication, the first thing I want to do is come in and just create a keychain. So I'm going to say key chain, we'll call it FP. I'll give it a key and maybe a key string of Cisco, maybe Cisco 123. Okay. Now, if we're doing interface-based authentication, we're going to go directly into that FabricPath interface. So I'm going to say interface Ethernet 4.9. Now, what we want to say is FabricPath, okay, IS to IS, and we're going to use these top 3 commands. Authentication, authentication check, and authentication type. Okay, so I'm going to say FabricPath. Again, I have a little flow that I go through. I'm going to say authentication check and just hit enter. That means we're turning on authentication. I'm going to say FabricPath IS to IS authentication type. We want to choose clear text or MD5. Again, they're going to say use a secure hash or something like that. They're going to elude you to use one or the other. So I'm going to say MD5. Okay. Then I'm going to say FabricPath IS to IS authentication, and we're just going to put in our keychain. FabricPath. Okay. So if we say show run int e 4.9, we now see we have IS to IS authentication type and authentication keychain. It does not show the authentication check. If you want to verify the authentication check, just say show FabricPath IS to IS interface Ethernet 4.9. Okay. We can see authentication check is specified, keychain is FP, type is MD5. Okay, we get all the information we need right there. So what I want to do is go over to 7K2. And we'll do the same thing. So first I'll say show FabricPath IS to IS adjacency. Okay, notice it's down now. It's not up. So we need to get the authentication going so that we can get our routing back in order. So what I want to say is key chain FP, key 1, key string Cisco 123. Okay. We'll go into interface Ethernet 4.13. We'll say FabricPath IS to IS authentication check, authentication type
MD5. Okay, we're turning on MD5 based authentication. And then the last thing we'll do is put in our keychain. So we'll say authentication keychain FabricPath. Okay, again, our same 3 commands. We're going to use these 3 commands in OTV too, guys. Exact same 3. Exact same sequence, just different spots we have to put them. Okay, so we'll hit enter here. We'll say show FabricPath IS to IS interface Ethernet 413. Okay, we have check specified keychain FabricPath authentication type MD5. Okay, so lastly, we'll just come in and say show FabricPath IS to IS adjacency. And we can see now that 7K1 has come back up because our authentication has been specified and matched. Okay, so not only does our keychains match, our key numbers match within our keychains. Also, we've specified MD5 on both sides. Had we declared clear text on one side and MD5 on the other, it wouldn't have worked. Okay, so we have to be very concise when we go in and do this. If we were to do LS or link state authentication, okay, actually authenticate the link state packets, we would do that in a separate place, but it'd be the same commands. We do that under the FabricPath domain default. Okay, the same place we did the root priority command. We just use authentication, authentication check, and authentication type all over again. Okay, but we'd go in there, and that would affect the whole topology. Okay, so once we did it in here, we'd have to do it everywhere. All right, you guys have any questions? If not, I'm going to turn you into labs. So the next one is tasks 9 through 10. Tell us how you really feel, Juan. So we're going to do section 2, tasks 9 through 10. Let me know if you have any questions. Do you guys feel okay with FabricPath? Is there anything else you want me to explore on the command line or explain to you further? There's a lot of information, man. A lot of information around this stuff. Tim, how you feel? If we really look at it though, I mean from an all-in-all standpoint, so if I just say show run FabricPath, there's really not a whole lot of config. I mean, look at, all that explanation I did, all the theory behind it, it all really equivocates down to about 10 lines of code. Okay, so it's not a huge config. It's a real easy config. It's just knowing behind the scenes what all's happening, right? So, you guys see it there. That's my root bridge 2 for multi-destination tree 2. Okay? So yeah, we're not talking a whole lot of configuration. This is with authentication tupled on top of it, right? So authentication we could even wipe out. We could push that out of the way. To get our just base system up, it's really about 6 lines of config.